Let me ask you something real quick. Have you ever written code where you had to treat one object one way and group of objects a completely different way? Like, if it is a file, do this, and if it is a folder, loop and do something else. Yeah, that's if-else jungle. Today I'll show you how senior developers delete that mess entirely using the composite design pattern. And by the end of this video, you'll be able to model tree-like structures cleanly, write polymorphic code, and spot composite in real-world systems instantly. After watching this video, you'll learn what the composite pattern actually solves, why developers usually get this wrong, and how to implement it cleanly in C# step by step. No theory dumps, just clean code and real examples. Welcome back to Code Like a Senior Dev, the series where we break down design patterns in a way they are actually used in production, not interview fairy tales. If you haven't seen the previous episodes, I'll link the playlist below. Before we touch Composite, let me show you what the problem actually is. Imagine we are building a file system. We have files and then we have folders. Sound very simple, right? Here's what most people do. Now imagine we want to calculate total size. This works, but it smells. Because the moment folder contains subfolder or we add a new type, this method explodes. Here's the big idea behind the composite pattern. What if individual objects and group of objects looked the same to the client? No if, no switch, just polymorphism. Well, that's composite pattern. The composite design pattern lets you treat individual objects and collections uniformly, represents tree structures, and push behaviors into the objects themselves. Files and folders, menus and submenus, employees and departments, same pattern, different story. Let's fix our file system the senior dev way. First, we define a common interface. It would have two methods. Moving on to the next step, we'll create a leaf object called file. Let's implement that. We created two private read-only variables to keep track of name and size. We'll create a constructor. Because we are implementing file system, that would mean we need to implement the methods. All right, so get name, that would return underscore name, and the get size would return underscore size. Simple. No surprises. Let's create a composite object and call it a folder. Folder item. Implements file system. Let's implement the interface. And let's do the same thing here. We create a private read-only string name and then a private read-only list of file system that can contain both folders and files. All right. Now we need to create a constructor that would initialize underscore name. So apart from get size and get name, we need to have another method that would help us to add the items to the folder. I'll make it items. All right. Get name should be straightforward. It should just return underscore name. The get size is gonna be a little tricky. So it should return underscore items dot sum item such that item dot get size, the method that already exists on it, and then sum of that. So necessarily this method gets the size of all the items and sums it up and gives you back when you call this method. Notice something important here. A folder contains the same interface as it implements. Now that's Composite. All right, now let's look at the client code. Go to the program.cs, and now let's say I have a file 1, which is a file item, and let's call it resume.pdf, and then let's say it's of 120 bytes. Right, next I'll create a file 2, and then I'll again do the same thing. This time I'll call it, let's say, photo.jpg, and then it'll be of 300 bytes. My bad, should be item. All right, now let's create a folder. And call it documents. Did a small mistake here, I think. Yeah. All right, now I'll add the above files to the folder. File 1. Oh. Okay. And I'll go with the file 2. And after everything is done, let's check the file size, or folder size rather. All right, let's run it. All right, 420. So 120 plus 130, that's 420. So our logic is working as expected. No if, no type checks. The client doesn't care whether it's dealing with one file or 1,000 nested folders. This is why senior developers reach for the composite pattern, because it's open for extension and it's closed for modification. It lets you implement clean recursion, it relies more on polymorphism instead of conditionals, and most importantly, your code models reality, which is the backbone of object-oriented programming. Just like any other good thing in life, this pattern also comes with few warnings. First thing that you need to take care of is you don't need to force composite when you don't have a tree-like structure. Don't leak child management into the client, and don't over-abstract simple problems. Composite is powerful, not a hammer for everything. So today we learn why if-else fails in hierarchical systems, how Composite unifies objects and groups, and how to implement it cleanly in C#. This is one of those patterns that once you see it, you start seeing it everywhere. If this helped you to think more like a senior dev, hit the like button, it really helps the channel. Subscribe for the next episode in Code Like a Senior Dev, where we'll stack another pattern on top of this one. And check out the playlist because design patterns make the most sense when you see them together. See you in the next one.